Hello. Now we will calculate the potential due to dipole along its perpendicular bisector. So we have selected this point P, which is at a distance x with respect to point O, which is at the midpoint of the dipole. So at this point we want to calculate the potential. There are two charges in the dipole, minus q and plus q. This charge I am calling 1 and this charge I am calling 2. So because of both of these charges, there will be potential at point P. I'll call those potentials as V1 and V2. And the potential at point P will be the resultant algebraic sum of those two potentials. Okay? So both of these charges are at an equal distance with respect to point P, and that distance is x square plus L square under root, because this is L and this whole value is x. So this is the hypotenuse, this is also the hypotenuse. So that will become perpendicular square, which is x square plus L square root of that. So I'll calculate V1. So if I calculate V1, this is the potential. The value of V1 will be 1 upon 4 pi epsilon naught minus q, because the charge is negative, divided by the distance of the charge with respect to point P, and that is under root of x square plus L square. This is equation 2, this is my equation 1. Now let's put the value of V2 also. The value of V2 will be 1 upon 4 pi epsilon naught q divided by, because there is a positive charge there, divided by under root x square plus L square. This is equation 3. So by putting these two values in equation 1, so from equation 1, we can get the value of potential at point P. So Vp will be equals to, we'll put both the values, so 1 upon 4 pi epsilon naught q upon under root x square plus L square, that's this positive value, minus of 1 upon 4 pi epsilon naught q upon x square plus L square, that's this from equation 2. And this whole value becomes 0. So the potential along each and every point over to this perpendicular bisector comes out to be 0, because the potential comes out to be 0 for all values of x. So that's the thing. When you calculate the potential along the axis, there is a non-zero potential along the axis. But when you calculate the potential along the perpendicular bisector of this dipole, the value comes out to be 0. Okay, so that is a derivation. Now we'll go further. Thank you.